The explanation of the back side of the notes for these quadratics on day 2 of Unit 5. As you can see here, I have the whole key here because I thought it's going to be kind of challenging for me to fit this all in as far as writing it well that you could see. So I'm just going to talk through it. I'm going to highlight where I would start. First of all, I do have this note here. Obviously, you can see. Let them play with this for a bit. I was hoping that you had kind of thought about this, you know, as a sketch, and just know that this is a quadratic, but the key is we have not given you the vertex. So that's what's different from the previous problem. So you have a point, you have a point, you have a point. Well, you know, what can we do with these things? Well, one note I made is that even though we don't have the vertex, so we can't jump to vertex form, we do have a point with an x coordinate of 0, which should help us with our calculations. Now, why is that? Well, if you look here to really the first phase of the problem, if I know this, if I have a y-intercept, then I know that the y value, when x is 0, can be applied. So if you look at right here, I'm going right into standard form. If I put a 0 in for x, a 0 in for x, I'll be left with my c value here. So the c value we can get as -5 right from there. Now, how does that help us? It's information. So basically, where can I go with that? And that's where, if you can follow this work, I'm now through to here. As you can see, this arrow splits off over to here and shows, all right, where is this coming from right here? Well, it's just standard form, ax squared plus bx minus, there is no c anymore. We have determined that c is -5. So we have that. We also, we have this right here. I'm sorry, let me back it up. I went too fast there. We don't have this one yet. So let's go in this direction and see where that leads us. Well, don't forget, we've only used this point so far. That's all we've used. But now that we have this one, we found our c value. Do we have x values and y values? Yes, we do. So really slow down, maybe pause the video at this point and see what I'm doing here. So I have 4 and -21. That's one ordered pair. So that means I have an x value and I have an f of x value. So that's where I put my f of x and then I put my x value in there. And if you're like, okay, well, I still don't have the a and the b, you're absolutely right, okay? If you follow this through right here, this 4 squared becomes this 16. This 4 stays right here as the coefficient. And if we add 5 to both sides of this equation, I have myself right here one equation where I have, well, kind of darkened it now, a little too dark, so let me back it up so you can see it. But I have myself, let me make it maybe yellow now. Okay, I have myself one equation. Well, that's not going to help me when I have 2 unknowns, so I need another equation. So you can see right off the bat, this is a way more in-depth example. So let's go back to green here. That point can be used over here by putting the -11, the 2, and the 2. And likewise now, we can keep this here, 4a, 2b, and then I don't know where the -5 went. That should have been right here on that one. But when you add 5 to both sides, you do get -6 equals 4a plus 2b. So when I put that one here, and let's make this very clear, we now have, out of all of this mess, we have 2 equations with 2 unknowns. So what we can do at this point is simply solve a system. I think I got a little ahead of myself. I didn't just put this over here. I actually modified this in the journey. You can see right here, multiply by -4. So that'll give me a positive 24, -16a, -8b. So basically what am I doing? I'm just getting into solving a linear system here. But when I do that and I add straight down, I get 8. When I add straight down, those cancel. When I add straight down, I'll get -4b. Which leads me, here we are, to a b value of negative 2. Okay, so now what do we have? Well, now we can switch back to red here and notice that what I started to do before was misplaced. Take this information, put the C negative 5, take this information, make the B negative 2, and then as you can see again, I'm using negative 11 and 2. That's straight up from an ordered pair right here. And if I crank this all out, I think you can slow down and follow that, you'll get an A value of negative 1/2. So if we have an A value, and we have a B value, and we have a C value, we should be able to write that one right there. Little intense, back it up, watch it again, but lots of color there, that's really pretty. Okay, going on to this next one right here, this is not nearly as intense. This is a simple, very simple quadratic application. If I tell you that there is a revenue function that depends on the price here, and you see A is negative, then you should know it's a parabola since it's squared here that's going to go down. We're going to have a maximum value. The maximum value is very clearly the vertex every single time. So this problem essentially asks you to find the vertex in two different parts. So what unit price, what P or X value here maximizes revenue? That's where we do X equals opposite of B over 2A, which is straight up from here. When you do that, you get 1900. So that's the price that will maximize the revenue here. Well, what is the maximized revenue? Take the 1900, plug it into the function, and you will get that value out. So that one's a little more straightforward. The other one's a little intense. Hopefully they'll help you with your homework.